Mechanism Friedel-Crafts alkylation, we must be carefully because our reagent is haloalkene. So, in the step number 1, which is we try to generate electrophile, so you must be find out based on to the classification, the class of haloalkene first. Means if we have secondary and tertiary haloalkane, okay, step number 1, we can form electrophile species. While if this is a primary haloalkane, step number 1, it must be form complex structure. Why? Because if the electrophile form, which is a primary haloalkane, primary is unstable. So we must be form the complex structure to refer to the stability of the structure. Okay, so we focus to the part 1 first. So according to our reagent, so I try to choose either secondary or tertiary, but the question given here is tertiary haloalkane. How you find out tertiary? Carbon that already attached to the functional group attach 1, 2, 3 alkyl group. So means this is a tertiary haloalkane. In the step mechanism, electrophile or carbocation should be formed. And the another step are same, which is step 2, rhenium ion. Step 3, loss of proton, and final product is formed. In the first step, which is our target is electrophile, so it must be involved from our reagent of haloalkane. So we already classify this is tertiary haloalkane. So it must be reacted with our Lewis acid. So why? Because the function of Lewis acid to help generate the electrophile species. So your intermediate product should be formed by using the mechanism. So you must be clarify where the electron occur, where the attack occur from the highest electron density. So you know that according to the haloalkane, kita ada lone pair pada halogen. So the first step mechanism, one of the lone pair here will form covalently bond, means this chlorine atom will form covalently bond with the aluminium, which is it transfer the electron towards the aluminium, and your intermediate product should be here CH3. This is remaining our another side branch CH3. So Cl and new bonding pair with AlCl3, and this chlorine atom consists only two lone pair. And when we check the value of formal charge this chlorine atom, 7 valence electron minus 1, 2, 3, 4, 5, 6. So this will become positively charged ion and aluminium will become negatively charged. So the next process is the cleavage should be formed. So which is this chlorine atom require electrons. So what happened? The two electron between carbon and chlorine will give electron directly towards the chlorine and the product formed as a carbocation or our electrophile species. So this is our species of electrophile. So this carbon will become carbocation and the rest is our side product. So this chlorine have the negatively charged because formal charge chlorine is 0, aluminium become negative 3 minus 4. So this is our charge is negative and this product we can call electrophile species, which is a carbo, okay? And when we are trace, this is tertiary carbocation. So means this tertiary carbocation is a stable species. So this species can further reaction for second step. So in second step, it must be involved by using our aromatic ring reacted with the tertiary carbocation. So one of the bonding pair here will attack carbocation because it need to form a covalently bond. With this carbocation means we added the electrophile into the one of the carbon atom to undergo process substitution with the hydrogen atom. So next, the product we form is arenium ion. So the two bonding pair are remain. So we added one of the substituent group, which is our new alkyl group here. And this neighboring carbon will become carbocation. So remember, this arenium ion can form the resonance. So what happened? The first bonding pair closer to the position positive charge will change the position here. So this is a new location, your double bond. Using this arrow and the new resonant form. So this is a new double bond and this is a location positively charged, remaining double bond and remaining our alkyl group. Okay, another stage, we have another step. Double bond yang baru, tukar tempat juga. So dia akan dapat double. So this is a new double location. So this is a positive charge carbocation. So this is the site of alkyl group. So this is arenium ion occur in resonance structure. So you must be bracket the structure and we label they are arenium ion. So remember to proceed for next stage, you must use the first structure in resonance. So in the step number 3, we need to form the specific product. So what happened? You must be replace the hydrogen here. It means you must be remove hydrogen and this must be reacted with our side product which is AlCl4 minus first here. Okay, so the first arrow must be take place. One of a lone pair here at chlorine will attack proton. So this is why stage 1 is loss of proton and the bonding pair between each carbon and hydrogen will stabilize between their own carbon and carbocation to form a double bond. At the same time, this bonding will break. So what happened? The product can be formed as a alkyl group here remaining because the process substitution already occurred. So we remove hydrogen and we replace by alkyl group. And our side product form is HCl plus AlCl3. So proof AlCl3 also can act as a catalyst because it formed again in this reaction. So in this mechanism also acceptable for secondary haloalkane as your reagent in reaction.